For this method of undetermined coefficients problem, we're going to have to modify our guess a little bit. So our differential equation here is y double prime plus y prime equals 2x cubed minus 1. I've also put out the homogeneous solution here. Right, and that one's not that hard to do real quick. So if we get the characteristic polynomial, it's going to be r squared plus r. That's the whole thing. And that factors into r plus 1 and r. So also it's like r minus 0. So the roots are negative 1 and 0. And so e to the 0x, that's just 1, so we end up with just a constant, C1. It's one of the homogeneous solutions. Which looks like it'll work, because if we plug in a constant, there is no y term, so by the time you get to y prime and y double prime, this C1 is completely gone. So that's one of the homogeneous solutions. So how is that going to affect our guess for the y particular solution? So normally we have y particular of x is, okay, well, we have a third degree polynomial on the right. We're going to guess a third degree polynomial. So it's going to be ax squared, third degree, ax cubed plus bx squared plus cx plus d. But there's a problem with that, right? This d here, I won't be able to solve, for the negative 1. And I've got essentially, if the d disappears by the time we get to y double prime and y prime, so I'll only have these three a, b, c to work with, but I'm going to need 4 unknowns probably to solve for the right-hand side. I need all 4 unknowns. So the trick to deal with this is we just take our normal guess and we multiply by x. Right, so now we have d times x is the lowest thing. That isn't this c1 times 1. This was d times 1. So now this one will end up working. Let's go ahead and just do that. We'll verify that it works and find the solution. So y particular prime of x. Let me write out actually. I'm going to write out the x pass through. It's a little easier to take the derivative. So that's ax to the fourth plus bx cubed plus cx squared plus dx. And now I'm going to take a derivative. So y particular prime of x. All right, that's 4ax cubed plus 3bx squared plus 2cx plus d. Then I've got y particular double prime of x. All right, well, that's going to be 12ax squared plus 6bx plus 2c. And now we're going to plug this into the differential equation and solve for a, b, c, d. So our differential equation is y particular double prime plus y particular prime. All right, well, that's going to be 12ax squared plus 6bx plus 2c. That was the y particular double prime. And then I'm going to add to that y particular prime. So that's 4ax cubed plus 3bx squared plus 2cx plus d. Make that a little nicer. All right. So now I'm going to gather the like terms. So it looks like there's only one x cubed term, so there's just 4ax cubed. But there should be 2x squared terms, so I'll leave a little space there, x squared. So there's a 12ax squared at the front, and there's also a 3bx squared, so plus 3b. All right, and then I've got my x terms. There should be 2 of those again. All right, well, there's a 6bx, and then there's a, 2cx. All right, and then lastly is the constant terms. I've got a 2c plus d. And now I'm going to get that to equal, well, going back to the right-hand side here, I have 2x cubed. So 2x cubed plus, I have 0x squareds plus 0x's and then minus 1. That's all the terms I have to match. So the easiest one to match first is the x cubed term, because there's only one undetermined coefficient in there, it's a. So I know that 4a is equal to 2. So then that's going to make A equal to 1/2. All right, well now I know A, and now I have 12A plus 3B equals 0. So 12A plus 3B equals 0. Plugging in my 1/2, that's 6 plus 3B equals 0. Well, that's going to make B equal to -2. All right, well that's that one, and then moving on I have 6B plus 2C. That has to equal 0, because there are 0 x's on the right-hand side. And I know B is -2, so this is -12 plus 2C equals 0. So that's going to mean C is +6. All right, and then we get to the last one here. We have 2C plus D. 2C plus D has to equal -1. I know C is 6, that's 12 plus D equals -1. So then that means that D has to equal -13. So that's going to mean the particular solution, y particular of x, equals, let's see, A, so 1/2, so x to the 4th over 2. And then B, so -2 x cubed, and then C, so that's +6 x squared, and then D, so -13 x. And that's the particular solution. We're done solving for that, and then if you want the entire solution to solve for initial conditions, you'd add the particular solution to the homogeneous solution. Then you could use that C1, C2 in the homogeneous solution to solve for any initial condition.